SwayamPrabha. Digital India. Educated India.
So very good morning to all of you. Good morning, sir. Sir, you can reduce the volume if possible. There is feedback. Okay, so how many days over now at IIT?
10 more days.
Huh?
10 more days.
What? You have come to that side. Somebody asked, how far can you go into a wood forest? Halfway. Correct? After that you are coming out, no? Okay, like that. Now when I said how many days over, you said 10 days more. Get the idea, no? Very good. Okay. So you are getting used to the IIT system. I can see one by one people walking in. Okay? If you are really passionate about knowledge, you will be here by 8:45. I was here by 8:45. Right? I was here 8:45. Do you know that? I didn't know this is the room. I was there in that seminar room. That is where you all had no initially.
Yes.
When did you move?
The second
Because after you have to move out of ICU to normal ward, no? All VIPs, when they come, it will be in the seminar hall. Later, it will be in a normal classroom because it requires enormous amount of expenses, overheads. That's why. But this is good enough for us, correct? Still AC is there. Where do you have? You have AC in your school, huh? I don't know. Do you have? Not necessary. Huh? Not, but you can enjoy. Just because it is not necessary, you should not enjoy. You can enjoy. So, how is the whole program? You enjoy? It's one of the very prestigious program. And then, you are all most fortunate few. Do you realize that? I don't know. How many of you realize? You should be wondering how I find myself here, yeah. It's so difficult, seriously. Because India is a big country. Even Chennai is a big city. Coimbatore is much bigger. So, what on earth will enable you to come here? I don't know. You are all great, fortunate guys who found an opportunity to come to a place like this and listen to some of the people on this side. Leave alone me. There are wonderful people on this side who would have given a phenomenal introduction to various aspects. Right?
Yes.
And you have one more. What is that thing? What do you do after the lecture?
Project.
Look at this. Project means what? Open-ended problem. Project means open-ended, right? Nobody knows the answer, including the supervisor, guide, mentor. He also, you will say, oh, let us try. That's the approach. Do you understand what I'm saying? I know, you can do this. Then what is the charm? I don't know, you don't know, let us work together. How wonderful you are. You get the idea, no? So, that is a phenomenal approach. And where do you go? One of the best labs in the world. Each one of them. I don't know whether you've seen. I don't know whether you believe in that. I can tell you, I worked here how many years? 40 years. I joined here 1975. I retired in 2015 at the age of 65. Then what happened? IIT Tirupati was started. New IIT, 6 new IITs in India. Because everybody wants one IIT in their town, district, town, village, everything, right, nowadays. So every state wants one IIT, one IIM, one this, that, etc. So when they started, IIT Madras was asked to mentor IIT Tirupati. So they asked people like me, cannot go home, retire, chalo, go to IIT Tirupati, mentor. Why? There immediately, within 2 months, children will come, students will come through JEE. Then we have to teach them physics. First, what do you teach? Physics, chemistry, mathematics only, no? So you need to require. That's why I went there. I spent nearly 7 years there. Huh? And in spite of that, it's growing very well. Now it's a beautiful place, phenomenal mountain thing. If you have an occasion later on to go to Tirupati, other than what you normally go to Tirupati. You know, right? You should go there and enjoy that campus also. Okay, very good. So, what do you like most over this When somebody at home or your friends, when you go back to your school, ask you what was the best thing that you had, what would you say? One or two. You raise your hand, answer, yeah. You should not shout. That's the normal Indian mentality. Shout together. Why? If I make mistake, nobody will know. Okay? But that is not the approach of a scientist. A scientist will say, no, Earth is not the center. Sun is the center of the whole system. And other planet, including Earth, is going around Sun. What guts that fellow should have had to say that? You understand what I'm saying? Nobody will believe him. Why? We all see day in and day out, the sun coming out from the east and going to the west. If you say, no. If this stationary, we are only moving. He was there yesterday, okay. Today I don't know what happened. Let us put him somewhere. There is one Keel Park, there is one hospital, no, somewhere. That is what he had. He faced all those problems. You know whom I am talking about. Whom? Nicholas Copernicus, then Galileo, all those people. And they suffered for telling the truth. Imagine, you understand? So science is not very easy. Don't think anybody can do science. It's very, very tough. And especially if you do new science. First thing what will happen? Opposition. Einstein was given Nobel Prize for what? Do you know? Why? What is he known for? General relativity. Okay, special relativity. Special relativity was a bang. Nobody thought a human being can think in those lines. You understand what I'm saying? Completely changed the whole outlook of asking questions. Correct?
Yes.
So what we are all doing? What did Einstein do? What did Newton do? Study for JE, go for 3 years, coaching, right? Come first in All India rank, finish your BTech in IIT, go to Cornell, MIT, Stanford, I don't know what it is. Then do research in the lab. Gravity. Did it happen that way? Newton. What did Newton do, As the story goes, whether it's right or not, I don't know. What is the story? Huh? I said don't shout, raise your hand and tell, because everybody saying that, I have to spread and then see what each one is telling. Yeah, what is that?
Sir, he was at Cambridge and during the plague here there was some thing that he just had to be by himself, so he just thought of it and he discovered this effect.
Fantastic. But I didn't look for that. Yes. That's all. All that plague and all that, nobody knew. I also didn't know, What everybody knows is, apple fell on his head. Somebody said that. Maybe it fell on the ground. I don't know. And he did something which none of us will do. What is that? What we all will do, he also did. Grab and eat, man. Don't tell me he didn't do that. He also did that. But in addition, he did something else, which none of us would have done. None of us, I can tell you 100%, none of us, including all you bright guys, would have done that. What is that? Ask a question. Leave alone anything else, right? He asked, what did he ask? What did he ask? Why did the apple fall? You all know the answer now. All very bright group, right? You know why? Gravity. What? I can't understand. With all my years of experience, I cannot understand. If there is sun, if there is earth. He also said that from the apple, he was able to connect it to astronomical objects. Right? That is the greatness. From a simple observation, he was able to go profound on the universe. You understand what I am saying? So what did he say? Earth is going around the sun because of gravity. Moon goes round the earth because of I cannot. I just cannot. Sun is there, earth is there. Gravity, attraction. That's what I understand. This all of you understand, right? Moon, earth, mutual attraction. What is the universal law of gravitation? Everybody will mug up and tell me immediately. What is it? Anybody can make the statement. Universal law of gravitation? No, sir, I said long time back. Somebody? Yes.
The force of gravitation is directly proportional to the product of the masses and inversely to the square of the distance.
Every body in the universe, that is a statement. That is a statement. Attracts every other body in the universe with a force proportional to product of masses, inversely proportional to square of the distance. Earth, sun, distance, attraction comes closer. Then what happens to distance? Decreases. Then what happens to the force? You understand what I'm saying? But what, yeah? Just now I said Earth is going around the sun because of gravity. How is it gravity coming? Anyone can help me? Can anyone help me, please? Anyone?
Clarification of the question, sir.
Gravitation?
Clarification of the question, sir. So you're asking us how gravity is helping the Earth.
Exactly. See, I understand mutual attraction should make the bodies come towards each other. Here is a situation where the earth is going round, not coming towards the sun. And you still use a gravity. Cannot. Oh, first question, Google, yeah? Middle stump uprooted. Yes, please.
Velocity. So it is actually attracted, that's why it goes.
So it has got a velocity, it is attracted.
Velocity in the tangent.
Tangential direction. Therefore, what happens?
So the attraction will make it to move in a ellipse.
You are not too bad.
I'm not sure, but the centrifugal force have
That's not, yeah. You have to use some centrifugal, something like that. No, everybody will get confused. Then very simple. Good. Very good attempt. I enjoy wrong answers. I encourage only wrong answers. I tell you the rules of the game today. Why? Nothing comes right at the first instance. Nothing comes right in the first instance. So when my children, my students in IIT long time back, they come for electronics. I taught electronics for several years. When they come for electronics in the lab, I will be there to bless them all inside in the lab. You know what I would say? Your circuit should not work today, go. That is a blessing. That's a blessing. You get frustrated. Why? We are all afraid of errors. I encourage people to get into problems where you get lost. That is the way to come out of it. If you face a problem, if you go away, you are not a scientist, man. You are not. Which scientist comes out successful when he faces a problem and running away? You understand what I'm saying? When there is a problem, that means it is waiting for you to solve. You understand? So, I want wrong answers. I told you, she gave a very good wrong answer. Fantastic. What is important? She said what she has in her mind. Most important. Everything else can change. Are you all scientists? You are all budding scientists. You can afford to make 2 + 2 5. No problem. Afford to say that. You understand? So there is nobody is belittled here when you give a wrong answer. I enjoy, I celebrate. I hope I don't have to say anything more here. Okay, now tell me what is who gave the answer to this question which I asked?
So for simplicity's sake, if you assume it's a circular object, so what, like you said, what the velocity is doing is that it's moving it forward.
I'm asking simple question, yeah. Gravity says this and this will attract. Here is a motion which is going round and not coming towards the object. Still you say gravity. How?
Sir, because the Earth has some velocity independent of acceleration.
So if I stop the earth and stop the sun and put them here, will they attract and hit each other?
Yes, they will fall in.
Good. Okay, you are almost there. Thank you. Is there a chalk piece? At least chalk piece is there. Is there a marker? I would ask. No problem. But duster is there. So who gave the answer correctly long time back? Not me. I also like you only. I was wondering what is happening. Then I saw Principia Mathematica. What is that? Newton. That fellow is a genius. Till Newton, Einstein came. Still he is a genius. Yeah, don't tell like that. Each one is a genius in their time. If Einstein were to born in Newton's time, he will be worse than Newton, I can tell you. I'm just joking. I hope you follow what I'm saying.
Yes.
So you cannot compare. The brilliance is individual brilliance. Okay, you cannot say this brilliance is more than this. For under his condition, he was doing phenomenal job, which nobody else could do. During his time, he did phenomenal job. Nobody else. That is how science moves forward, right? So what Newton said: take an Earth, not too bad. Looks like a circle, no? Okay. Then what happened? You have a Himalayas. On top of Himalayas, you put Bofors gun. I'm losing some time, but it doesn't matter. These are all important, nice. I put a Bofors gun here. You know Bofors gun, everybody knows in India. I fire bullet, cannon. What will happen? It will go like this. Will it go like this? No. Everybody says no. It will follow a path of parabola. Because how many you have written exams, show that path of a projectile is a parabola. Right? Get 20 out of 20. Then you all should be able to answer this. So, when the bullet comes out with some velocity, it falls on some ground. What is this distance called? Range. So, if I want to increase the range, what will happen? I will increase the velocity. Horizontal velocity, I will increase. If I increase the velocity, what will happen? Range will become more. Correct? So, it will come and hit here. Somewhere it will here. After that, what will happen? It will keep on trying to look for the ground because it is coming under parabola only. But there is no ground, so it is traveling almost parallel to the earth. Then what will happen? That is not bullet coming from behind. So what happens now? If I don't take the Bofors gun, quickly come down, I will be looking here, the gun will come and hit me from behind. Do you follow what I'm saying?
Yes, sir.
So, assuming there is no air resistance, that also important. So, it will come and hit like that. So, this is the principle of, therefore, what is happening? Now you bring in all your ideas of centripetal, centrifugal, etc. What is centripetal force? Where do you get it? Can I buy from a shop? Is there where is centripetal? Have you seen any centripetal force anywhere? That is not centripetal force. That is the tension of the string.
Sir, that is centripetal.
So, centripetal force wants to convert something which is available as a centripetal force, right? Something like that. I mean, we're saying in a crude way. So, gravity says, oh, you want centripetal force? I will be a centripetal force. Then gravity becomes a centripetal. What is a centripetal force? Center seeking. For any curvature or any movement along a circle, you require a centripetal acceleration. One acceleration which is always towards the center. Therefore, there is only change in direction, no change in magnitude. That is what centripetal force. It provides only the normal acceleration. It's called normal acceleration. Okay. So that is what is responsible, and therefore that bullet is in a state of free fall. You understand what I'm saying? It's falling, looking for earth. But there is no earth because it is parallel. All this happened when? Right at the time of Big Bang. If I have earth here, sun here, either stationary or almost on the same line joining the two centers, then what I said would have happened. You understand what I'm saying? That is, the probability is so small. So what happens? When the splinters from the Big Bang comes, one forms the sun, the other one comes with some velocity, part of the whole thing. And when it comes, due to the loss of energy, due to its burning, no, it's coming, burning initially, right? And so some energy loss. When it comes very close to the sun, it is grasped by the gravity of the sun, and it starts coming into the gravity of the sun, and it starts going round and round, cools off. That's how it all happened, right? Okay, now there are a lot of such questions. If I go into that, 1 hour it will go in this. You know what is a tide? So many consequences came, all from simple observation of apple falling to the ground. How wonderful. How wonderful. Because he didn't do what all your teachers and parents tell you at home. What is that they do? If you don't get an answer to the question, skip, go to the next question. That's what everybody says. So in the exam, will anybody say, no, please solve some more and then go? No. Hey, don't waste your time, man, because their time management is important. Yes.
Sir, one small question, sir. So, sir, in this answer, we're going in a circle, sir. Why is the Earth going around the sun in like an elliptical?
Ellipse. Okay, that's a good question. So, this is always very difficult for many people to understand. Why it is going along the Earth in an elliptical orbit. So, this is what our friend first time who said this? Kepler. How? Looking through the telescope forever, every day. Okay, he collected so much data. From purely empirical data, he was able to see. Okay, so the elliptical orbit is part of a conic section. You know the conic section you would have heard. So all of them have got the same characteristics. Especially, for example, the most important concept in that is the conservation of angular momentum, for example. That is true for elliptical orbit, circular orbit, all those things. Okay, it is not because our mind can understand only circular orbit, which is very characteristic everywhere. We are not able to extend it to an elliptical orbit, but it obeys the same kind. There is again the normal acceleration. The acceleration can be different depending upon whether it is at the apogee or perigee and things like that. Okay, so there is no harm when you actually do. Newton did that. Kepler did it as an empirical law. Okay, equal area. It covers equal area during equal intervals of time, dA by dt, right? That is again a reassurance of conservation of angular momentum. Okay, so there is, all of them follow the same normal acceleration, and the gravity provides the acceleration, except that velocity changes as it goes along the orbit. When it is very close to the object, the sun, it is going faster. When it's far away, it's going slowly. Then only it will be able to cover equal area. Do you understand what I'm saying? So it's all mathematically also it is consistent. Why elliptical? Ellipse, big. What shall I say? One specific condition under the elliptical orbit is circle. When A is equal to B, when the major minor axes are equal. Okay. Okay. Now, man. Now, what I want to do is what? Take you all to apple tree. No, not that way. I want to provide Newton-like situation here. How will I do that? I will keep on doing some crazy ideas, experiments here. After I do a crazy experiment, what I will do? Simple thing. Ask questions. That's the simplest thing anybody can do. I have been doing that for so many years. I don't have to answer. How wonderful my situation, right? But you all have to give me wrong answer. What I kept on telling you, don't worry about answer. Give me only wrong answer. You understand? You get the logic? But, there is an important but. What is that but? Should not shout. You should write, give me the silliest answer, I will enjoy. I don't know whether you know. Richard Feynman?
Yes.
Everybody should know. Right? Great physicist, great teacher. I don't know, great. Everything is great. When he walks into a classroom, you know what he will do? He will bring chocolates. Why? If somebody asks, sir, how do you say 2 plus 3 is 5? Very good silly question. Come on, catch this chocolate. Because there is nothing like a silly question in the world. There is nothing like this. For you it is silly, for him it will be a profound question. For another it will be making him think in a different way. So you should never brush aside any question as silly or intelligent or bright and things like that. Every question should be attacked on its merit. Do you follow what I am saying? So that is very important. Therefore, don't worry about your answer. You raise your hand, tell without blinking of an eye, whatever you think comes to your mind reasonably. Just like that, don't say 2 plus 7, 9. It's correct, sorry. 2 plus 7, 6, something like that. Don't tell. Sir, you want a wrong answer, right? I'm giving wrong answer. Not that. So I understand the logic. Now, some of you would have seen these experiments. Have you? Anybody? You have not seen a rubber ball, huh?
Yes.
Then you said you are keeping quiet. This is the first experiment. What is that experiment? Rubber ball bounces. Right? What type of a collision it is? If I want to make more complicated question, that's all. In IIT, JEE, we all do that, no? Make simple question complicated. I thought that is what JEE is all about. No, yeah. You all have a wrong idea. In JEE, I have been a chairman, I have been an examiner for several years and all that. What is the idea? Don't ask one single concept. Link 2-3 concepts so that you will be able to apply this concept in real situation. That is all. What is the syllabus? Only +2 syllabus. Nothing more. 11th and 12th. You have seen, no? So they will say, don't ask any tough question. Every question should be simple to approach. It should be, you must be able to answer if you work longer time. You understand what I'm saying? The bright guy, perhaps he will do faster. Not so bright will take more time for one particular problem. Another problem will change it. This bright fellow will become dumb. The dumb fellow will become bright. It all depends on the problem, right? You understand? So, but our job is to eliminate people who are all just like that writing exam. Mostly 90% right. Correct? You know that, right? 90% right because my neighbor's son is writing, I will write. Your father says you write, you write. I want to become a scientist, artist. No, you're right. JEE, you have to you have to go to US. That's what it is, right? So much of pressure, unfortunately. But you keep yourself away from all those pressures. You focus on only what? Knowledge. Don't focus on exam. I have a center in Adyar. I started after my retirement, second retirement. What is the name of that center? Falling apple. You know why? Apples are falling. We don't find Newtons. All Newtons are busy writing exams here. You understand? We want people to ask questions without worrying about the answer. Asking the right question is more important than answering them. Those who ask the right question are the guys who come to the long, who never get convinced till they are able to fully understand the whole idea behind it. Right? These are the important things. So this is a rubber band. What type of collision? There are only two, yeah. Inelastic, elastic. Some people said inelastic, some people say elastic. What is the difference?
Elastic collisions, the energy is completely conserved. Stays as static in potential.
Only energy conserved.
And momentum is also conserved.
You have to say complete answer. Good, very good. So, in this case, what is being conserved? Only one. The conservation of one is conserved. What is that one? Yeah. Momentum. Right? Why? Because it undergoes deformation. Because it's flexible, no? It undergoes deformation. There is a small amount of heat, millikelvin maybe, and some energy loss. Sound also produced, no? That is again, etc. Therefore, that is the reason it is not coming to the same height. Correct? Then air resistance. So many things. See? So in JEE and all that, they are trying to see whether you are able to understand the whole concept, idea behind it. What are all the factors which are affecting the movement? It is pure common sense to a large extent. But if you know the principles of physics, you will have much more. You may be even work it out quantitatively. What is the last year, this year, etc. And that is a kind of people we want later. When you go back after doing an engineering, I have studied electrical engineering. I know everything in microcontrollers, the Arduino, this, that, etc. You go there. What your person in the US, maybe you are there, yeah, I don't know, in some lab. Or somebody in India. Now India is also becoming a great country with semiconductor and all that. So they ask you, what do you know? I learned 8-bit processor, that 16-bit processor very well, thoroughly. Can you do 128-bit processor can you design? Out of syllabus, sir. then you know what they will do? Throw you out. So what you learn throughout your career is to enable you to think and do new things. Not for, if it is a old thing, I can use a technician. Why you need a scientist or an engineer? Do you understand what I am saying? So your focus should be how to take it further. That's the most important, that nobody realizes that, unfortunately. Anyway, it's okay. So that is why I'm asking. You have to understand, analyze the whole thing. You may be able to solve, you may not be able to solve, it doesn't matter. But at least you should be able to formulate what are the factors that will affect a given situation, how to handle it. That is the most important thing. Okay, so it is a rubber ball, it will bounce. Now you know what I'm going to do. Do some magic. All of you should give me 100 rupee ticket at the end. If it is real magic. What is that magic? It's liquid nitrogen. So she knows what I am going to do. What I am going to do? I am going to cook it in liquid nitrogen bhaji. I am going to put bhaji now. Right? Into liquid. This, my good friend Prem has put me, is so passionate. He's an IT specialist. He has got his own company and all that. But he's so passionate about physics, he will always come with me wherever I go. Right? To help me as well as enjoy the physics. So I have here a pot full of liquid nitrogen. Can you see the liquid?
Yes, sir.
Where is it here? Where? Yeah, liquid should be there, no? Why? What is the boiling point of liquid nitrogen? Anybody? What is the boiling point of liquid nitrogen? I said like this. Not shout. Say something. I told you what I want. What answer?
Wrong answer.
Wrong answer. 2 degree, 20 degree, 200 degree, -5. Whatever you tell you, what is that? Sabash. Very good wrong answer. Next. Fantastic wrong answer. Very good. So first you should say minus. If you are telling in Celsius. If you are saying in these things, it's okay. Kelvin is okay. But it is 77 Kelvin. 77 Kelvin or minus 196 Celsius. 196 Celsius. 196 means what? At 0 degree, what do you see? Ice. Right? At normal temperature and pressure. If I take it nearly 200 degrees below, nearly 200, 196, yeah, then only nitrogen can become liquid. And where is nitrogen? All over the place. Where from I got it? Right across in that building, yeah, low temperature lab in physics. Yesterday I came only for this, to collect liquid nitrogen. Right? So, this is liquid nitrogen. But because it is very low temperature, the moment it is exposed to even this AC room, which is 23 degree or something, so hot compared to its own temperature, and therefore it immediately goes into gas. Right? Now, who wants bhaji? I put it here. Boiling, yeah. That's what will happen. No, don't come near. Everybody can later see also. Boiling. Now what is this? Balloon. So now what will happen? What will be my mood? Put everything into that. Correct? Put balloon into this. But you have to handle carefully. Only I can handle, not all of you can do. What happened? Drop, huh? What do you want me to do? Can you see that? You saw a wonderful phenomena which you read right from your school, earlier school classes, no? Can anyone tell me what is the phenomenon you observe?
The gas compresses in void.
Good. Condensation, good.
Sir, the gas, I think it's
I want some laws. LOSS syllabus. LAWS. Can you tell some laws?
Sir,
Pa. Pt is equal to nRT. All mathematical. They become mathematically phenomenal. What is that, yeah?
Ideal gas.
Gas equation. So, it is Boyle's law, Charles' law, all combined together. Right? So, what is happening here? You have air inside the balloon. I put it in liquid nitrogen. So, what I am doing? I am cooling it. To what temperature? Very low temperature, minus 196. So, what will happen? When you P is proportional to T at constant volume. P is proportional to V at constant. That also inverse. P is proportional to T. V is proportional to T at constant pressure. PV is equal to proportional to time. That is temperature. That is what? See, something is happening. A budgie breaking. Already, nariya pottingla. All sir. So now what I am going to do? Let me do the experiment and then come. What I will do? Did you say rubber ball? Can anyone, don't take it, don't take anything, just sit where you are. These are all, you have to be safe. You understand? So you should not touch. You don't know how to handle low temperature. I am doing for 50 years as I already told you, so I can do it. You should not touch till I tell okay. Okay, now, you want in, what? Once more, what is that? What, yeah, each is 25 rupees. Each. See, that is why I brought so many. I know. Huh? I can even put in the middle. No, it's not safe, man. I'll do it here. Those who cannot see, here. Don't touch. Don't touch. ₹25. Immediately I'll break one more. Poor sir. Nariya poda. He's making a shop out of this. Budgie shop. See, he has already got one more ready. Which place? See, science will work here, in Timbuktu, everywhere, yeah. Don't say it should work here. Everywhere it will break like that only. Turn that side. I need some space. Be careful. Don't touch. Don't touch. Splinters you have to remove, yeah. Okay, enough. That is the end of it. One more. Okay, I'll do outside. People are asking outside. Can I? Nobody is there, yeah. You are. Oh, already it broke when it was in my hand. Okay, why is it breaking? Why is it break? Wait. Listen to me. Why is it breaking? This I said gas law. Right? You got that thing, no? This is gas law. Now, where is the one which came this side? Is here? What? What? Yeah, what has happened?
Sir, this might be a dumb answer, but sir,
Yeah, I want a dumb answer.
sir, it might be because the ball didn't undergo deformation because the liquid nitrogen would have cooled all the molecules.
That is almost the answer from everybody. Little more.
Sir, it rigidified, right, sir?
Okay, it rigidified. That also everybody knows. That's why it breaks. But what is happening? Something you have to tell. What's the property which decides this? What is this material? Can anyone tell me? Rubber. What is rubber? In material, I'm asking. Is it a metal? Is it a non-metal, organic, inorganic? Something you tell. What is that?
Polymer.
Polymer. Rubber is a naturally occurring polymer. Latex. Where do you get latex? Trees. From trees. You all know that. In Malaysia, in Kuala Cochin, here, there, everywhere. You have, what is it? Kottayam, somewhere. No. A lot of rubber plants are there. So rubber is a polymer. What is a polymer? Long chain molecule. Means what? The same molecule will repeat multiple times, millions of times. thousands of times. Because of that, it is highly flexible because it's long, no, like a snake, and it has got a backbone. So it has got an excellent thermal property. You can shape it into different things. So you can make an aeroplane out of that. You can make a rubber ball out of that. All kinds of things. But unfortunately, they found that it is not degradable. So what did they say? Say no to plastic. This is also plastic, right? Plastic is a general term. So it's a polymer, and now what is happening? The polymers have got two characteristic temperature when it is in solid form. One is melting from solid to liquid. Second, glass transition temperature, Tg. One is Tm, the other is Tg. What is Tg? Glass transition temperature. Tm means melting temperature. Glass transition temperature, what will happen? Because I take it to very low temperature, the molecules, how will they be normally? If I take this wooden box or this chalk piece, if I go like Tompkins in Wonderland, you know Tompkins in Wonderland? No. George Gamow. Do you know George Gamow? Phenomenal guy. Phenomenal physicist who was responsible for alpha decay, tunneling effect, all those things. He is a great writer. He wrote several books, phenomenal books. Wherever it may be available, download. You can download somewhere. Tompkins in Wonderland. Tompkins explores the atom. 30 years that shook physics. All of them are his books. Yes. So what he said, Tompkins in Wonderland, he will provide a character called Tompkins. He's almost not a scientific guy. So he will be very, very anxious to learn many things in life. So he will go into the atom. It is all Gedanken experiment. What is Gedanken experiment? That is given by Einstein. Gedanken in German means thought experiment. Thought experiment means what? For all Indians, it's all very familiar. Many things are for us only thought. We cannot reach, right? In those days. Now it is not, yeah. Now India is showing the way to the world. We can do everything. Our kids, our scientists can do phenomenal things. But in those days, it's all only thought process. How will it be Empire State Building? 102 staircase. How is Burj Khalifa? Now we are also building such things. You understand what I'm saying? So, thought experiment means you can perform an experiment in thought, in thin air, but you should not violate any known principles of physics. That is the whole idea. So, in the thought experiment, Tompkins in Wonderland, when you go down to the molecular level, how will the molecules be? Everybody will be like that. One more molecule here, one more like that. No, they will be dancing. You follow what I am saying? Any temperature, higher temperature, molecules will be, because we model them in principle like a rigid ball linked through springs. All of them. Imagine lot of metal balls linked through springs in all directions, 3 dimensions. Then what will happen? If I hit here, what will happen? It will vibrate and stop. You understand what I am saying? So, but at higher temperature, it will be vibrating violently. If I keep on cooling, what will happen? The amplitude will become less and less. Right? Because the amplitude becomes less and less, the springs will become rigid. Right? So, if I hit on one side, that stress cannot be communicated to the rest of the body. If it is able to communicate to the rest of the body, what will happen? Nothing will happen. It will do like this and come back. But if it is all rigid, if I hit, what will happen? It will break. That's what happened in the ball. Because I took it to a temperature below the glass transition temperature of rubber. What is that number? If I ask what, you will have to flip open, Google, you will get, check. Okay? Because I went below the glass transition temperature, it became a glass. So when I drop, it breaks. When I bring it to normal temperature, it becomes a rubber again. I don't know whether you have seen it. Unfortunately, it's all closed. It was white on the top. Is there any? Yeah, you can see. What is this? What is this? I have done only one experiment. I have 20 experiments. Anyway, it doesn't matter. It is not the number of experiments that matter. How you understand, how you argue, that those are the important. What is this? Can you see? What is this? Don't tell the process. Understand the question, answer correctly. What is this? Ice. That's all. Ice. Where is it coming from? I have no ice anywhere. Beautiful. From the atmospheric water vapor. You all know it. If I take a glass tumbler, put some water and put a lot of ice cube, keep it here. After half an hour, if you come, it will be sweating outside. Why? Because it's very cool. The atmospheric water vapor comes in contact and then it becomes water there. If you wait too long, maybe it will become even sometimes ice. I don't know, very rare, but it can happen. So, this is ice. And if I blow into this, I don't know if you have seen, if I blow into this, what will happen? I'll get white smoke. You have seen that already, when I put the rubber ball, there it was coming up. What is that? White smoke. Nitrogen is white smoke, huh? Where, yeah? I don't see any smoke here. Nitrogen is here. That's what you said. Water vapor in the atmosphere comes into contact with the low temperature molecules of nitrogen boiling from the trough. Immediately freezes into nanocrystals of ice. And so it becomes white in color. It becomes opaque. After some time, what happens? Gone, like your cloud. What is a cloud there? Supersaturated steam. Okay? And if there is a cool wind or some dust, then it will be forming small droplets and it will come out as rain. Right? Okay, that's all right. So I keep on going like this. Now what happened? We will take another ball. Yes.
So the glass transition temperature is temperature at which the...
It goes from the plastic to glass, elastic to glass. That is the temperature, Tg. Okay, now you see another ball. What is this ball? Everybody knows. Ping pong ball. What is B? Its mass? 1 kilogram.
10 grams.
10 gram. Microgram. Yeah. So in all such things, you should be able to give a reasonable estimate. That is called a guesstimate. You know, what is the width of this hall? 2 kilometer. 20 centimeter. That's a wrong answer. You can be wrong by several meters, but you should be reasonably close. You understand what I'm saying?
Yes.
So you should say 10 meters. It may be actually 9 meters. You say 10 meters, 1 meter wrong. Wonderful. You are great. Right? Okay. So this is 2.4 grams international standard. I don't know that this is the same type. I bought some local market, but it can be different. But it is very low. It may be 2.5, 2.3 something. So it is very, very light. So if I ask her to blow, what will happen? What will happen? Fly. Correct? Come. Let us see. But to make it simple for her, I take a funnel. I'll take a tube. Hold the tube on the other side. Now I'll hold. Wait. Don't do anything till I tell you yes. So she is going to now blow. I'm going to put this here. I'm going to blow. She is going to blow. Strong. Okay? And what will happen? I hope so. I don't know. Oh, sorry. I will frame it in a way where every one of you will be able to answer immediately. What is that? A. The ball will not come out. B. The ball will jump off. C. The ball will come some height and stay there. D. None of the above. That's very important. Okay? Then what you will do? Tick, tick, tick. 80 out of 100. So tell me, is it A, B, C, D? I hope there is no D. D is there, huh? Okay. Okay, so let us now try. It's good time to try. I missed it. I think, what was idli, huh? Breakfast, sit down. Huh? What is that? Oh, boy sauce only, huh? For you, what is it? Nothing. Oh, huh? Bread, okay. That's not enough. Somebody wants to try with idli? Please, come on. If you say like that, you come. I always The person who is prompting is the person most skilled. Come here. Otherwise you won't prompt. Come here. Please come here. Enjoy. Just enjoy. It's only fun. It's only fun. Come on, he's going to make a hole. Thank you. Thank you.
Yeah, there's
All kinds of doubts will come here. Sit down. I'll list all the doubts at the end. Now can we do the thing, sir? So now what we do is we don't believe in human power. We are graduating to machine power. What is this? It's a what is this? Blower. Blower means what? It is suck air inside, right? No. Good. Everybody understands. What is a blower? Blow air out.
Sir, one more student is going to.
Professor Rangarao from chemistry.
No, keep
Okay. So can you see the blow? Now for simplicity, I am replacing this. The same thing. Don't tell me I put something inside and all. Yeah. There is no, here I am not a magician, I am a scientist. Okay? So I am going to put it there. Good. So what I am going to do now, I am going to blow high speed air through this. Put the thing. Now what will happen? A, B, C, D. Come on. So when is the ball coming out?
Once the blowing is stopped.
Only when the air flow decreases, then only it comes out. Even when I switch off, it is not coming out. I don't know if you have seen that. Switch on, sir. See, I already switched it off. So it takes fraction of a second before it comes out, right? Now let me do another variation. Inverted. I put the funnel on the other side. I make this into a nozzle. I pinch it little bit. Sorry. I pinch it little bit. Now let us see what happens. Some people in the back could not see, so let me show that it really can. Somewhere in between. Come. Here it is, sir. Come here. Put it there. Suspend it. Why are you worried? You are worried, huh? Don't be worried. Etc. You can do 20 experiments like this, only using this blower and all that. Okay. Now question time. After that there will be a break. What is the question? Why is the ping pong ball not coming out of the funnel? Super. That's all. You put some scientist's name and say effect. Bernoulli effect. Beautiful. But what is that here?
The pressure is, since the airflow is coming like this, there's pressure on top of the ball also. That's
Excellent. Excellent. Good. So, I'm sure many of you know it. I'm very confident about it. But then it is important that you should realize that somebody sitting in one corner of the world is a Swiss mathematician. Bernoulli, he was doing that. He finally, you know what happened? He died. I don't know how people killed him because they didn't know who is that guy. They asked question. That fellow is fully concentrating on his calculations, and all scientists are crazy people. You remember Einstein? So it's like that. They are very, very crazy. And so what happened? That fellow said, "What? You are impertinent. You are not answering my question." Dish him. That's all. Finished. The great guy is gone. We lost a great scientist in the world, Bernoulli. And what he did, he's sitting in one corner, he did some calculation, he found that when there is a motion of a fluid means what? That which flows is a fluid, water, gas, all those things, right? The pressure around it will become less. The pressure applied by the flow in the surrounding will be less. And therefore what happens when the air comes out through the small gaps between the funnel and the ball? So what happens? There is a ball, there is a air coming this side, there is a air coming inside. If I call V1, if I call this V2, which will be larger? V2 will be larger. Equal, right? No. You have studied. You have studied this equation. What is this equation called? Equation of continuity. All people you know, yeah. What is the area here? This is A1. This is A2. Which is larger? So A1 is less. Therefore, what will happen to V1? More. So the velocity of, so V1 will be greater than V2. So you get very high velocity. Because it is having high velocity, the pressure due to that air on the ball will be less compared to, he very well said, the pressure due to the air above the thing, which is stationary, will be more. So it will never allow the ball to come out. Even when I invert, what happens? Gravity joins. I hope you understand. Still it is not able to do that. Therefore, it is staying there. So what is the use of this? Any use at all?
Suction.
Spray. You spray, no?
What?
Deodorant. Fleet.
Yes, sir, yes.
All those things based on principle. You have a tube. You blow, immediately what will happen? Air pressure will decrease, the liquid will come out and spray. As simple as that. I have a demo, but I didn't bring anyway. So there are a lot of such things available. That is all. For that we are studying about Bernoulli. Shame on Bernoulli. If I want to go to a conference in New York, what do I do? Take a bullock cart? What do you do? Plane. Who is driving it? Bernoulli and Newton. You think the pilot is trained to only manual. The fellow who is really flying it is Bernoulli and Newton. Physics. So, this is what you should understand. A young person sitting in one corner doing some calculation can bring about a change in every one of our life. That is technology. The knowledge is transferred in terms of your technology. You get aerospace, you have got, I don't know how many airports we have in India now. Everywhere. One is coming very close to IIT, they said in another 10 years. Yeah. Okay. So there are so many airports coming all around. And how is that? So the flight is something like that. You all know, most of you know. What is this called? Aerofoil. And this is the pilot sitting at this point. And this is the runway. It will always be at an angle which is about 4 degrees. It is called the angle of attack. The flight will not be like this. It will be like this. Some small angle will be there. So now what happens? He is driving it. I have done too much. 4 degrees. It's not 4 degrees. He will run it like this, on the runway at high speed. So what will happen? Air will go. Which one will be greater? V2 or V1? V1, obviously, because it is very smooth. Okay? There is nothing stopping it. So it will be very good. So what will happen to the P1 on the flight? What will be the P2? Which will be larger? P2, because velocity is less, up is more. P2 minus P1, you will check in the dial. When it goes beyond mg, what is mg? Mass of the aeroplane, people sitting there, baggage, crew, everything. Take it, fly. As simple as that. Do you follow what I am saying? So, a simple observation that when I have a ball of air, it has got one energy, that is called what energy? mgh, right? And then it has got, is it moving? No. Velocity is 0. What is the kinetic energy? 0. But it has got molecules inside air. They are all sitting pretty? No, they are moving very high speed, hitting each other and hitting on the walls of the balloon, if it's a balloon, okay, or ball. So that is what we call pressure. Momentum transferred by the molecules on the surface is what we call pressure. So it has got a pressure energy, it has got a potential energy, it has no kinetic energy because velocity is 0. Now it moves very fast at the same height. What has increased? Something has increased. Kinetic energy. Potential energy remains constant. Out of the 3, 1 is constant, 1 has increased. So what should happen to the third to make energy conserved? That is what Bernoulli theorem. So Bernoulli theorem is a reassertion of conservation of energy. This is what we omitted for the exam. No, not you. I am talking to somebody. Okay, sometimes we think it is very complicated. It's not at all. If you understand it properly, it's very simple to follow and go forward, right? So that is exactly what happens here, and that has got phenomenal application potential. Okay.
SwayamPrabha. Digital India. Educated India.